It's important to distinguish between absolute measure and gauge pressure or relative pressure. Both of these pressure measurements are taken with gauges, so this terminology might be a little misleading, because absolute measure is also taken by gauges and gauge pressure is also taken by gauges. But some of the instruments and gauges work in absolute pressure and measure absolute pressure, and some others measure relative pressure, also known as gauge pressure. So what's the difference? In absolute measurements, either which way, a pressure measurement is a comparative measurement. A comparison is made between inside or outside, or pressure being measured versus a reference. So in absolute measurement, the instrument is comparing a pressure to be measured against vacuum, where there's no pressure, absolutely no pressure of any kind. So that's how absolute measurements are done. And in relative pressure or relative gauges work by measuring pressure differential between, again depending on the point of reference or frame of reference, between a reference pressure and the pressure to be measured. It could be an inside pressure and an outside pressure, as in a tire gauge, inside the tire and outside in the air, or inside a pressurized cylinder like propane and outside the cylinder. You get the idea. I want to also illustrate the difference between the two with these tiles and pounds that I used in explaining a little bit about PSI. In this I illustrated in a video using this square tile, well actually it was that one, using the square tile, 1 square inch, and 1 pound mass was placed over it. In this scenario, the pressure on the surface of the tile is 1 pound, because the surface of the tile is 1 square inch. So you have 1 pound over 1 square inch, 1 psi. This pressure is a gauge pressure or a relative pressure. If I remove it, that would mean that now there is 0 psi on it. I put it on, it's got 1 psi, I take it off, it's got 0 psi. But that 0 psi is not true, because there is pressure on it right now as we speak. We are just maybe 30 meters above sea level, pretty negligible. The pressure on this one is exerted by the air. Everything that's made of matter has mass. Air is made of matter, air has a mass, and so it's going to weigh something. The thickness of the atmosphere over this square inch is such that it equals to about 15 psi. It's 14.7 at standard temperature and at mean sea level. I believe it's 45 latitude, because the air is a little thicker over the equator than it is at the Arctic or the poles. So there is about 15 psi pressure on it right now. That's absolute, because that's against vacuum. If this was placed in vacuum, there would be no air directly above this one. That would be an absolute 0 pressure in vacuum. But right now it's got 15 psi pressure on it, and if I put 1 more pound on it, now in absolute terms, now the pressure on the tile is 16 psi. I take it off, now it's down to 15, now it's back up to 16. You get the idea, right? So that illustrates the difference between absolute and relative. I also have this is the demo here. This 14.7 is almost 15 psi, is measured at mean sea level, and if you go up to a tall mountain, something like a Mount Everest, or at cruising altitude of most passenger jets, the pressure outside is just 5 psi. The pressure drops. That's absolute pressure, and that's also absolute pressure of air, because the thickness of the atmosphere over this surface area, all the thickness of the atmosphere all the way out to outer space, is such that it's at sea level, it's 15.7 psi. You take the same square tile up to the top of the Mount Everest, and it's only going to be 5 psi over the same. That's also why people have to take oxygen with them. There's not enough breathable air and not too much oxygen in that very little breathable air as well. So that's what happens to pressure. These are absolute pressure figures. Look at the situation that I drew here with a balloon in it. That would be a helium balloon or a weather balloon. It's a little underfilled. At sea level, the outside pressure is 15, and it's pressing against the balloon in all directions, 15 psi. Inside the balloon, let's say we filled it with 10 psi. So, if you put a pressure gauge here to the opening of the balloon, the pressure gauge, most pressure gauges would measure the differential pressure between outside and inside and would show you 5 psi. That 10 is absolute pressure, that 15 is absolute pressure. If you attach a gauge or instrument that compares the pressure inside against vacuum, it will show you 10. But if you put on a gauge that just references the pressure differential between inside and outside, not the pressure differential between inside and vacuum or outside and vacuum, but just the differential, you can see it's 5 there. Alright. And as the balloon ascends or goes up, it gets whereas it looked underfilled, it looks very well filled, and in some cases it can even pop, depending on the tensile and material properties of the balloon and how much flex it has. If the outside pressure is only 5 and the inside pressure is still 10, because the balloon is now at the top of the Mount Everest there, then the pressure differential is still 5, whereas this was maybe minus 5 psi, now it's plus 5 psi. But that's what you could measure with a pressure gauge. So this would be minus 5 psi and that's plus 5. In terms of absolute pressure, the pressure inside compared against vacuum is still 10 psi, and the absolute pressure outside, minus 5, is still an absolute pressure. So that pretty much is where my illustration is going between absolute and gauge pressure. Divers need to use pressure. They use pressure that is that also relates to depth, meters or feet of seawater, and if you're diving underwater, you're gonna have the pressure of water measured as well as the pressure of air on top of it, on top of the water. It's important to know which gauge or which of the measurement modes your indicators and instruments are set. The pressure of gases or pressure of air is atmospheric pressure. The pressure of gases in general, because that could be helium floating in hydrogen, or helium floating in nitrogen, I don't know, or CO2 in argon, or whatever else is used in weldings, the shielding gases. So when it comes to gases, the terminology is pneumatic pressure readings. Okay, when it comes to air, it's atmospheric pressure, and when it comes to water, it's hydrostatic pressure. Last few seconds here. I got a liter of water here or so, and as I immerse this steel nut here, just as with air, the thickness of water above the steel nut is what's causing a hydrostatic pressure on this one. And if I lower it and put it down all the way to the bottom, now there is more pressure exerted on the same steel nut, because there is a thicker layer of water directly above it, pressing against whatever surface area that nut has. So the same principle that has to do with depth of air or depth of water, it's applicable everywhere. And it doesn't have to be water, it can be any liquid, it can be even concrete. concrete has a hydrostatic pressure, and it has to be taken into consideration with formwork design. And coming back to the instruments, it's important to know in most of the cases which system or which frame of reference you're taking your measurements in, or which frame of reference your numbers, your results for pressure relate to.